In this video, I'm going to work several integration by parts examples, and I may fumble around or stumble around on some of these, and feel free to fast forward me or skip around to the examples that you specifically need help on, but I'll try to increase in difficulty as I go along and show some new stuff along the way as well. But I'm going to start off with something kind of maybe simple here. I'm integrating the product of the square root of x and the natural log of x with respect to x. And off to the side, I have a liate written down. That's just a mnemonic device to help you remember what factor is most beneficial to be u and dv. So liate, I'll just kind of write it down here in order. L-I-A-T-E. That stands for logarithms. So if I have a logarithm in the problem, I want to let u be that logarithm. And then whatever comes next, I want to be the dv. I stands for inverse trig. A is any algebraic expression. T is regular trig. And E is exponentials. So when I look at my list here, I have a logarithm, the natural log of x, and then the square root of x, which is just x being raised to a 1/2 power. I would call that an algebraic expression. So if I follow this kind of guideline, then I think I want to let u be the natural log of x, and I'd want to let dv be the square root of x, which I'm going to call x to the 1/2 power because I'm about to use some power rules. All right. Well, the parts formula calls for a du and it calls for a regular v. So I'm going to find du, and the derivative of the natural log is 1 over x. And then the integral of x to the 1/2 power, that is, I need to raise it by 1, so 1/2 plus 2 more halves is 3 halves. Multiply out front by the reciprocal of that new power, 2/3. And this is v. Meaning if I were to take the derivative of 2/3 x to the 3/2 power, 3 halves comes out front, multiplies with 2/3, and the coefficient is gone. Reduce the power by 1, and there I have dv, the derivative of v. I'm going to write down the parts formula to help me memorize it. The integral of u times dv is equal to the product of uv minus another integral of v du. That is the parts formula. I'm going to be using this formula in every example in this video. All right. I've got u times v. So that is the natural log of x being multiplied by 2/3 x to the 3/2 power minus the integral, I've got to do some more integration, of v times du, which we found to be 1 over x dx. So before I go any further with the integration process, I'm going to simplify as much as I can. Outside of the integration, I could just maybe rewrite the 2/3 out front, try to clean that up a bit. I typically write the x variable out front of a logarithm as well, just so we're not confused as to what is the argument of that natural log. May be even beneficial to write those arguments in parentheses, so we're really not confused. Now this is integration, so constants can come out. I'm going to pull that 2/3 out of the integration process. And then I've got an x to the 3/2 times 1 over x, or you could think of that as maybe x to the -1st. but there's definitely going to be some reduction that goes on there. If I have 3/2 x in the numerator and 1x in the denominator, then I should have x to the 1/2. So again, I'm just pulling out the 2/3 coefficient out front, and then x to the 3/2 in the numerator position, x to the 1st in the denominator. Just do the subtraction, 3/2 minus 1 gets you back to 1/2. When I integrate, I'm going to go back to 3/2, but let me get there. Just recopy all this down. I'm going to do this integration. The power is raised by 1, so it goes back up to 3/2. That power's reciprocal comes out front. Treat this as a product. I'm done with the integration process, so now is a good time to write down the plus c. I've got this constant trailing along. And I'm just going to now clean this up. And simplifying these integrals is always just what you think looks pretty. I guess I could call that 2/3 square root of x cubed natural log x minus 4/9 square root of x to the 3rd power. And I mean, you're really done. I guess I do see some commonalities. Both have a fraction that a 2/3 could come out. I could pull out this common root of x cubed, or yeah. So you're done here in your box of that answer. I think I'll just rewrite this. If I factor out 2/3 square root of x cubed, that leaves me with the natural log of x minus 2/3. I don't know. One of these sounds good. You could probably go even further and... Nah, probably just stop there, yeah. Alright, so integration by parts, the way this works, if you're integrating a product, you have to decide which factor you want u to be and which factor you want dv to be. Find du, find v, shove it into the parts formula, do some more integration, simplify, and Lie8 can help you figure out which is u and which is dv. Let's go to another example. The integral of the natural log of x. Okay, well I already see a big problem because I just said we're supposed to be doing products. I don't say product. Let me think. I know the derivative of the natural log is 1/x. But I can't do that in reverse. That doesn't give me a natural log. Alright, well, I guess technically I can call that a product. This is the natural log of x times 1. So if I follow the Lie8, ln of x is clearly first as a logarithm. And then if I say this is being multiplied by 1, maybe that's algebraic 1. I'm going to just see if this works. I'm just fumbling around here. But if I let u be the natural log of x and dv equal 1 dx, then I can find du and I can find v. I need to differentiate u. I said earlier, I know that one. That's 1/x dx. And then if I integrate 1 with respect to x, that's just going to pop out an x. So v is simply x. All right. Then I just apply the parts formula. I'm going to write it down because I'm trying to memorize it. The integral of u dv is equal to the product of u and v minus the integral of v du. I'm simply going to plug in my information into this formula. I need u times v. ln of x times x minus the integral of x times du, which is 1 over x dx. Simplify before I try to integrate. I'll call this x ln x. Oh, that's convenient. X divided by x is just 1. So I'm subtracting the integral of 1 dx, which we just said was x. Go ahead and put my constant on there. I guess it's probably smart to factor out that x. And I'm going to box my answer. This is the integral of the natural log of x. Now this seems like it might come up a lot. We knew a derivative rule for the natural log. If you want to sit down and memorize the integral for the natural log, I would memorize it as x being multiplied by the natural log of x minus 1 plus c. But this came from this integration by parts formula. So memorization is not really what you're trying to learn in this class. When you go off to calculus 3 and whatever, yes, it's helpful to know, I guess, these integrals by heart, but those you're going to forget. So what's more important is this process. So if you come across the integrating the natural log or something maybe similar, wink wink, something coming up, I'd rather you know this process of the parts formula. So really memorize the parts formula and practice it. But in future problems, if you need to integrate the natural log of x, well, there it is right there. All right, let's move on. The tricky part here was that was a funky looking product because the algebraic expression was just 1. Oh yeah, here we go again. Again, I'm given just a single thing, so this doesn't seem to fit in the parts strategy. I don't see a product at first glance. I see inverse trig. I know derivatives for inverse trig. I could derive those and memorize those, but integrals, all right. I think I'm going to use that same idea where I'm going to treat this as a product where inverse sine is being multiplied by 1. So I'm going to let u equal the inverse trig. I want to write down that Lie8 just to make sense of this. Or it's just like a good habit, probably. I don't have any logarithms. I do have inverse trig. I stands for inverse trig. So I have arc sine here of x. And then algebraic-wise, I'm multiplying this by a 1, so I have that product. I'm letting u be the first thing on this list. So I'm letting u be arc sine. I'm letting dv equal 1 dx. Now I let u be this arc sine because I know the derivative of arc sine. If you need to refresh yourself, that's maybe fine, but this you do really need to have memorized. The derivative of arc sine is 1 over, that's a square root, of 1 minus x squared dx. Arc cosine looks very similar, has like a plus sign in there. Arc tangent looks very similar, but there's no square root. Anyways, I need v now, or the integral of 1 dx. The integral of 1 with respect to x is 1x. And I'm now ready to apply the parts formula. I'm going to write down the parts formula. I'm trying to memorize this thing. The integral of u dv is equal to uv minus the integral of v du. plopping in information that I know. Arc sine times x minus the integral of x times that fraction. Oh dear. Okay, I can make that pretty. This integration, I think u substitution is going to come in handy. If I let u be the base, and there's a 2x, yeah. Let me rewrite this. Okay, I've applied the parts formula, but now I have this integration to worry about. Okay, I think u substitution will come in handy here. Let's try that. If I let u, now this, don't let this be confusing. In fact, if you want to call this w, maybe that's better. I already have a u in this problem, so letting u be something else may be confusing. So w, another u, sounds really good. So I'm going to let w be this 1 minus x squared. So then dw is equal to a negative 2x dx. I want the negative to go away. I want the 2 to go away. I'm going to divide them over. So a negative 1/2 dw is equal to 1x dx. Let's see if I can do some substitution here. I'll use the red to maybe help us out. Yeah, that black minus sign is this black minus sign. But now I have another minus sign inside this integration that I can pull out. I'll go ahead and pull out that negative. I'm going to pull out this 1/2 outside of my integration process. Inside here, I have a x dx is dw. And down here I have the square root of w. Good. Okay, I can handle this. This is a power. This is w being raised to a negative 1/2 power. So then I can apply the power rule for integration. If that's w to a negative 1/2, then I'm going to raise the power by 1, making it a positive 1/2. Multiply out front by the reciprocal, and I still have that now positive 1/2 out front of that. Converting from w land back into x land, doing some simplification. That's just a square root of 1 minus x squared. I think I forgot my c, but now is a good time to put it back in there. So I come up with x times inverse sine of x plus the square root of 1 minus x squared plus some constant. I claim that is the integral for arc sine. And just like the integral of the natural log, sure, you can sit down and memorize this thing. It looks somewhat familiar, but really I want you to memorize this process, and memorize this parts formula and practice this process. We can handle similar inverse trig this way. I think there's some in your homework to try out, but they should kind of follow this process where we're letting dv equal 1 dx. All right. Let's see what we got next. Oh yeah, product. I'm integrating x squared e to the x. Looks easy off at the start. Liate. X squared is algebraic. E to the x is exponential. So I should be able to just shove this straight into a formula. All right. Let's let u be the first thing on our list, x squared, making du 2x dx. Then the next thing on our list is dv. dv is the exponential, which, yes, is easy to integrate. v would just be e to the x. Write down my parts formula. The integral of u dv is equal to u v minus the integral of v du. Then I can just, this is what I'm trying to find, the integral of this product. So it's going to be equal to u times v, x squared times e to the x, minus another integral, v, which is e to the x, times du, which is 2x dx. I think I'll pull out the 2. Oh man, this is not as easy as I thought it was. Because if I want to integrate x e to the x, this is another product, so this is another parts. Okay, I'm going to put a big red star right here. So if you're fast forwarding, maybe you'll pay attention. And this is, I'd call this repeated integration, maybe? So repeated integration by parts. So I've come across that -2 integral of e to the x, x. That's another product. That's another u dv situation. I think I am going to use the same variables this time. That's how I work parts, is with u's and dv's. I'm going to change color though, maybe to help differentiate. I'm now focusing in on this integration right here. I'm going to let u be the first thing on our list. That's going to be the algebraic x. While I'm on u, the derivative of u is just dx. V, or dv, sorry, is the exponential, which I know how to integrate. v is e to the x. That's it. All right, let's see if I can write this down. I'm using the parts formula again. All right, here we go. X squared e to the x is still out there. -2 is still out there. This integration is becoming another parts formula. I think I'll put it in a big parentheses. And the parts formula is, I take u times v, which is x times e to the x. I subtract another integral, will this ever end, v du. So this is e to the x dx. Okay, yes, this integral will stop. The integral of e to the x is simply e to the x. So just be careful with the notation here. I had that first uv kind of separated out. -2 times this integral. The integral became its own parts formula with 2 parts in there, 2 pieces. So that 2 is being multiplied by this. And it does look like I can factor an e to the x from this parentheses, and then maybe an e to the x from that binomial. So I just pulled out an e to the x from this common binomial, and then this difference now has a common e to the x. I'm going to pull out. Oh, I don't know if, yeah, I can just leave it alone. I could call that minus 2x plus 2, or I'll just leave it like this. Fully factored, I guess. All right. Let me make sure, check my notes, make sure I did that one correctly. Yeah, in my notes, I distributed the -2, but that's the same thing. All right. So this one was unique, or a little bit harder maybe, because it didn't look like the parts formula helped us at first. It did take, though, the x squared, and it reduced it to a x to the first power. So one more time brought that x, like it got rid of that altogether. So it eventually did end. So integration by parts, you may have more than one you've got to deal with. Ooh, okay. Not too bad. Let's try this next one. E to the x times sine. Okay, again, looks straightforward. If I want to play around with Lie8 to help me determine which factor I should let be u. No logs, no inverse trig, no algebra. There is trig. Sine of x is a trig function, and then e to the x is an exponential function. So I'm going to let u be the first thing on the list, sine of x. While I'm on u, I might as well find du. The derivative of sine is a positive cosine. dv is the next thing on the list, e to the x. Oh yeah. Seems to be a common practice. Let that dv be the exponential because they're easy to integrate. v is simply e to the x. I'll throw this into a parts formula. I'm going to write down the parts formula, trying to memorize it. The integral of u dv, so something and something else's derivative, is equal to u times v minus the integral of v du. Sine times e to the x minus the integral of e to the x times cosine x. Oh no, it did not end. This looks just like that. I have another integration by parts. This kind of looks like it's just going to go on forever, right? This will spit out a sine, sine will spit out a cosine. Oh well, let's see what goes on here. So I'm focusing in on this integral. Using the same Lie8 system, I would let u be the trig function cosine of x. Du is a negative sine x. dv we're letting be the exponential, and v is e to the x. So I'll shove this into the parts formula again. I'm not going to forget this original term out here. Now, this single integral is becoming two things. So when I subtract, I do need to emphasize these parentheses, because I'm going to subtract everything that I write down from here on out. And it's just the parts formula. So I go through and say u times v minus the integral of v du. I gotta be careful with these negatives. That minus sign is just a -1 being multiplied around in here, so I can pull it out and make that a plus integral with inside the parentheses. Oh my gosh, this is never going to end. This is back to the e to the x sine of x, but let me clean it up. I think I can show you something. In fact, to help us see what's going on, I'm going to rewrite my problem. So remember, that was the left-hand side of this equation. I kind of stopped writing it, but that was my original thing. I'm going to write that down again. The integral of e to the x sine x with respect to x is equal to, I'll write this out front, e to the x times sine of x minus this thing, which I'll call e to the x cosine of x. Now this becomes a positive, but then I'm subtracting it. Those minus signs are deadly. And I'm subtracting the integral of e to the x sine of x. So I did like 5 steps in here with those minus signs. Make sure you don't get lost. All right, and about this point, I'm about to just give up because this is what I started with. So if I just repeat this process, I'm just going to go in this like cyclical pattern over and over and over again. But notice what we just found, or what this is. The integral of e to the x sine of x dx, that's what we're looking for. That's what we started with. That's what we were asked to find. It's sitting right there in this equation. In fact, I see a positive integral here, and on the other side of the equation I have a negative same integral. So these are like terms. I'm going to put them on the same side of the equation. I'm going to combine my like terms. I'm going to take this negative integral and add it to the left-hand side. So 1 plus another one of these, I'm going to have 2 of these integrals. And I'm trying to find e to the x sine of x dx. It's equal to e to the x sine x minus e to the x cosine x. Well, I was looking for one of these integrals and I found 2. So how can I take this equation and just get one of these? Well, I can simply divide everything by 2. I'm going to put a big old green star right here in case someone's fast forwarding. They know this is a new thing. I don't know what to call this. This is fancy stuff. Technical term, fancy stuff. So I was integrating and I came up, part of my answer was what I was looking for. So I just kind of combined my like terms. Now I'm going to go through and divide everything by 2. So then what I was looking for, the integral of e to the x times sine x with respect to x, is equal to all of the right-hand side being divided by 2. I think I'll go ahead and factor that e to the x out in this process as well. So the right-hand side of the equation divided by 2 is what I was looking for, the integral of e to the x times sine of x dx. So this is a common occurrence with integration by parts, where it just kind of repeats itself a lot. Of course, that's going to happen with like sine and cosine. There's other functions where this may happen. So what you do is you just get them on the same side of the equation and then divide by whatever coefficient you've got. There's probably a better technical term for fancy stuff, but that's what I'm calling it. All right. My next example has maybe some new notation. We've got those limits of integration back. So let me show you how to handle that. All right. I would like to integrate from 1 to e the natural log of 2x with respect to x. I can see 2 ways to maybe handle this. I'm going to write up here. There's probably a more clever way. If I would just take the old product rule for logarithms and rewrite this, that would instantly create 2 integrals that I could integrate. But I'm not going to do that. I'm not going to take the easy road. Let me write that down. Clever using product rule for logs. But let's do parts. We need practice using the parts formula anyway. So this is one of those where the product may not be obvious, but you can always say it's being multiplied by 1. So I'm going to let u be the logarithm, the natural log of 2x. I'm going to let dv be 1 dx. V is an easy integration. I get x. Du isn't too bad. The derivative of a natural log is 1 over the argument. This does kick out a chain. I need to multiply by the derivative of that argument, which is a nice little 2. And this is all with respect to x. I see that the 2's will reduce. Du will clean up to be 1 over x dx. Okay, I'm ready to apply the parts. And I just wanted to show you this notation with these limits of integration. The way we handle this is we just say this is going to be equal to, when you start writing the parts formula, uv and then before I continue on to the minus integration, I'm going to write down my limits of integration. So I do need to evaluate this from 1 to e, but I'm not done with the parts formula. I'm still subtracting the integration of v du. So that's x times 1 over x. And this integration, of course, has those same bounds, 1 to e. Now, this is not to be confused with u substitution. With u substitution, we switched from xland into a different variable u. This u is not that u. This is still in xland. We're still dealing with x's, so there's no need to change the limits of integration. They are still technically x's as in inputs. Okay, I'm going to leave this notation alone for just a second while I clean up my integration. Maybe I'll move that x out front, though. X times 1 over x conveniently goes to 1, so I'm just integrating 1 dx again, which is going to spit out that x. So I have this product, x times the natural log of 2x, that I need to evaluate from 1 to e, minus x that I need to evaluate from 1 to e. Several ways to maybe do this, but I'm going to keep them separate like that. I'll just now shove in my upper limit of integration. So I have e times the natural log of 2e minus 1 times the natural log of 2 times 1 minus, now this single term is about to become a difference. So emphasis on the parentheses. I'm subtracting now something really big, where I plug in e minus, I plug in 1. So I'll just distribute that minus sign in this next step, see if I can clean any of this up. Let's just see what that looks like. I do see something that can pop out. So back before I said it would be smart to start with the product rule of logarithms, I'm about to use that product rule right here. So I have the natural log of 2e. There's a rule that says I can take a natural log of a product and rewrite it as the sum of those two factors. So watch this. I could say this is e times the natural log of 2 plus the natural log of e. That's what I meant by I could have taken my original integration and separated it into two separate integrals, which would probably have been easier to integrate. But the parts formula worked just fine, but I am going to use that log property here to help me with my simplification. Because I know the natural log of e. The natural log of e is just 1. And if I were to distribute the e, I see some like terms. So I'm going to distribute inside these parentheses e times the natural log of 2 plus 1e minus the natural log of 2 minus 1e plus 1. These e's are canceled altogether. The first two terms have a natural log of 2 in common, so I might as well factor that out, leaving me with e minus 1. And then on the very end, I have this plus 1 that I did not factor from, so it's just trailing behind. I think I like that answer. If you made it to this step with the arrow, you know how to do parts. Yay! Continue doing integration by parts. After this arrow, this is just simplification, so it's very wishy-washy on where you should stop. But if you're needing to factor for future like parts of this problem, depending on what you're doing with these integrals, this would be a nice like factored form maybe. All right, so that's an integral with those limits of integration. It's the same idea. You still need to evaluate them at the upper limit minus evaluate them at the lower limit. Let's do what looks like our last example. The integral of x times sine of x halved. So I see parts, I see a product, x being multiplied by trig. Where x is just algebraic and sine of x over 2 is trig. I'm going to let u be the first thing on the list. X, du is nice and simple, 1 dx. Then dv is going to be sine of x over 2, dx. And, oh man, the derivatives, or the antiderivatives of those trig functions with arguments always get me. I have to think about derivatives before I can do antiderivatives. So y'all may know what v is, but I'm going to fumble around and figure this out. Okay, to get sine, it comes from cosine. So I know the derivative of a cosine x over 2, because I know the argument stays the same, would be a negative sine of x over 2 with the chain rule of 1/2. So I'd need the negative to go away, so I'm going to put a minus sign in front of my cosine. And I don't have a half, so I'm going to put a 2 out front to get rid of that half chain that comes out. Alright, the derivative of negative 2 cosine x over 2. Well, the negative 2 you can just kind of ignore. The derivative of cosine is a negative sine. You keep the argument, you multiply by the derivative of the inside, which is just a constant 1/2. Clean this up. A negative negative is positive, and half of 2 is 1. Okay. It's been a while since I've taken calculus. Maybe that's fresh in your mind. It took me a while though. All right, so I get v to be negative 2 cosine of 1/2 x, or x over 2. Okay, then I can use parts formula. This will be equal to u times v minus the integral of v du. So in this game, I've got negative 2x cosine of x over 2 minus the integral of, well, just that. Negative 2 cosine of x over 2 with respect to x. I can pull out the negative, I can pull out the 2. You know what? I'm dealing with cosine, so this seems to be that like over and over pattern. So let's just continue though. Remember, with these, if they do just kind of go on forever and ever, I'm looking for my original question. So here is a cosine. This is no good to me. But it's about to turn into sine again, so maybe it'll look something like that. I don't know. All right. I'm just going to copy this down. I'm going to clean this up. Then I've got this integral. Okay, the integral of cosine of x over 2. This should be nicer. Oh, I don't have to do parts at all. Oh, this is not too bad. Oh, okay, never mind. This is not going to be the repeating thing because I know the integral of cosine. It's just sine, positive, and it does have a like a reverse chain rule, so there's a 2 popping out. I'm done with the integration. Maybe I'll write a plus c out here. And you can always, these antiderivatives, if they don't make sense at first, you can just find the derivatives to check yourself. The derivative of what's inside my brackets, 2 sine x over 2. The 2 would come out. The derivative of sine is positive cosine. Same argument. This spits out a chain of 1/2, but that kills the 2 that we just pulled out, getting the cosine of x over 2. Good. Okay, I'm done here. I guess I could multiply those 2's. Maybe factor out a negative 2. I don't know. That looks good to me. So I probably showed this example just so you could see me fumble around with these antiderivatives. It's been a while, so it's okay if you struggle. The way I remember them or the way I get to them is I know my derivative rules. So play around with the derivatives until the antiderivatives make sense. Okay, those are a lot of examples on the parts formula, but I think maybe you have the tools to handle some more. So go do some homework and some more examples, and I'll see you in the next video.